Um, Hello everyone. Today I am responsible to show you how to set up the network topology using VirtualBox. So the network consists of one Linux server and one Linux client. The server has two networks uh, interface, which one interface connected to the internet through DHCP and another interface connected to an internal private network. The client is connected only to the internal private network. So for the first one, which is we start from the server, we open the VirtualBox Manager and select the Linux. We select the Linux server virtual machine. And then we click the settings to the network, and then on the adapter one, we set the uh we set it into the NAT or maybe bridge adapter if it was allowed. And then the purpose is to allow it to access the internet via DHCP. And then go to the second adapter, and then we set to internal network, and then we name it like us we use internet, or maybe you can use other names, and then click OK. On the client side, and we select the Linux client virtual machine, and we do the same thing. We open settings and the network, and then we enable adapter one and set to internal network, same as the server. And the name also the internet. Yes, and then we click OK. Then we go. After that, we go inside the server and open the terminal, and then we're gonna set the hostname into server. As you can see, we will type the sudo hostname set hostname to server, and then we check our hostname by typing hostnamectl, and then you can see is this. And then we need to set the static IP address for the server. So we so we will type this sudo nano and this thing to open the nano editor for our to set our static IP address for our server. So as you can see here, I set it into 192 and then all of this based on the mini project requirement. And then the net mask is 255.255.255.0. Then when we close, and then we will check we will check we want to check the IP for the server correct or not. We will also use IPA, and as you can see here on this ENP0S8 is this 192.168.1 and 254, just like as we said here. Okay, and then we want to ensure our server can connect to the internet. We just ping the internet using this command, and as you can see, we we transmit 4 packets, and then we have a 0% packet loss, which means our connection is good. While we are here, I want to tell a difference about the difference between static IP address and the dynamic IP address. So as you can see here, what I'm doing right here on the server, where I put the address 192.168.1.254, that was a static IP address. It was manually typed IP into the network setting by the administrator or the user like me. No, not the user, only administrator. About dynamic IP, dynamic IP was assigned automatically by the DHCP server. Yeah, just like the DHCP server will give the client the IP address for they to use. The static IP address is permanent. It will never change unless the administrator want to change itself. But the static IP address, it was temporary. It changes on reboots or maybe when the lease time is expired. Uh, about the static IP, where the server has. The server was permanently assigned to the IP address that was typed, which is this, so that it would not change, so that the client will always know. No, the client will always find where they want to find the gateway. Where for the dynamic address which the client will use, they will be granted in a the DHCP pool that was set by the administrator as well. Uh, I think that's all. Thank you.
Okay, hello everyone and welcome. Today we're going to look into DHCP or Dynamic Host Configuration Protocol. So before we start, I want to tell something. Every device on a network needs a unique IP address, a subnet mask, and a default gateway to communicate. In a small setup, you can type these things into a machine manually, uh, which is the static IP address. However, in a large network or maybe in a corporate network with many devices to connect, doing this will become very impractical and very self-burden. It takes too much time and it's very easy to make typo or accidentally give two different computers the same IP address, which is create a conflict and knocks them offline. So this is where DHCP comes to solve this. DHCP or Dynamic Host Configuration Protocol is a network management protocol used to automatically assign IP addresses and other network configuration parameters to devices connected to a network. DHCP simplifies network administration by eliminating the needs for manual IP address assignment and reducing the possibility of configuration error. So in this project, a DHCP server is configured on a Linux server to automatically provide IP addresses, subnet masks, default gateways, and the DNS setting to client machines within the internal network. The implementation of DHCP improves network efficiency and ensures that device can communicate properly without requiring manual configuration. So let's hop on into the how to set up the DHCP server. So first thing that we must do is install the DHCP daemon by typing the sudo apt update. Then after that we will run the command sudo apt install ISC DHCP server. After we install it, we will bind the daemon to our internal network interface. We will use the nano editor. So we will use the command sudo nano. We're gonna make sure that in the nano there will be type interfaces v4, and we must put the name of this server, the name of this server. And then third, we will define the subnet and pool scope exactly as in the stated in the project. We will also use the nano editor. So as you can see here, what we will put in the nano editor in the dhcp.conf right here. And last, we will start and enable the service by restart the DHCP server and then enable it. So now let's move on to the demo. So let me show you the configuration files, so you can see that I do the correct settings. And I'm very sorry about the video. It was kind of blipping because I don't know what happened to it. So yes, let's start by typing this. and then as you can see, it was the server is bound to ENP0S8, and the IP range. Oh wait, okay, sorry. As you can see now, let me show you the other settings. Mhm. Now, as you can see, the server range is, so as you can see that the server range is uh, strictly between in a range from 192.168.1.5 to 192.168.1.10, as you can see in what I have configured in these settings. Okay, now let's test. Let us check the status connection to prove that the service is actually running and active, so without any errors. Okay, so as you can see, the status show that it was the green one. The green one is actually active, so this means that our DHCP server is active. So now let's move on into the client side. So as you can see here, I already run the IPA to check whether the client already has been assigned with the we have already assigned with 192.168 between the range that I already set. As you can see, it didn't the client doesn't have it since I didn't run the command to request the dynamic IP address for it. So now I will run the command to request the dynamic IP address. So then the client will receive a new IP address from the DHCP server. So let's go. Okay, let's wait. Okay, now it's done. Let's run the IPA once again to see whether the IP address has already been assigned to it or not. So as you can see there, the third one, which is the new IP address that the DHCP gives it to the client. So yes, it means that the client successfully received an IP from our DHCP server, and between the pool range. So right now we will conduct a ping test to check whether it was connected or not. Let's try ping this client to the server. As you can see, I receive I succeed. Oh my god, I'm sorry. The ping was successful. The ping was succeed with a 0% packet loss. And then let's try ping the client to internet. and as you can see, it was failed because it was blocked. And then let's move to the server, and then we ping to the internet. And as you can see, it was successful. I was successful to ping the internet from the server. So that means that the external it has an external access. So that's all from me. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Arifuddin bin Sufyan. I am member 2 for the operating system mini project. My part here is to demonstrate and configure the SFTP server service. First of all, SFTP stands for Secure File Transfer Protocol. It is a protocol used to transfer files between a client and a server via an encrypted connection. It uses SSH technology, which provides authentication and protects the data during file transfer. Now, I will demonstrate the configuration process. First, I update the Linux package repository using the command sudo apt update. Next, I install the SSH server. Because SFTP only works through the SSH service, the command used is sudo apt install open SSH server. After installation, I start the SSH service using sudo systemctl start SSH. Then I enable the SSH service to automatically start after reboot by using the command sudo systemctl enable SSH. I check the service status using sudo systemctl status SSH. The output shows that the SSH service is active and running, which means the SFTP service is ready to use. Now, I create a user account for SFTP access. The command used is sudo add user SFTP user. The user will be used by the Linux client to connect to the SFTP server. After creating the user, I configure the SFTP settings by editing the SSH configuration file. I add the following configuration: match user SFTP user, first command internet SFTP, root directory SFTP, allow TCP forwarding no, X11 forwarding no. This configuration restricts the user to SFTP access only and improves security by limiting access to the assigned directory. After completing the configuration, I restart the SSH service by using sudo systemctl restart SSH. The SFTP server configuration is now completed. Next, I will demonstrate the testing procedure. First, I check the IP address of the Linux server by using the command ipaddr. On the Linux client, I connect to the SFTP server using SFTP at server IP address. After entering the password, the connection is successful and the SFTP command interface appears. Next, I test the file transfer by creating a sample file. Then I upload the file to the server using put test.txt. The file is successfully transferred to the SFTP server. To verify the file, I use ls. The uploaded file appears in the SFTP directory, showing that the file transfer is working correctly. I can also download the file from the server using get-test.txt. This confirms that both upload and download operations are successful. In conclusion, I have successfully installed and configured the SFTP server using OpenSSH. The testing procedure proves that the Linux client can securely connect to the Linux server and transfer files through SFTP. Thank you.
For web server, So, first, what is a web server? A server is a service that provides web pages and other web resources to users through a network. In our project, I use Apache 2 as the web server software. It is because Apache 2 is an open source web server that uses HTTP protocol to deliver web pages to clients. So, before configuring the web server, I will first ensure that the network connection between Linux server and Linux client is working properly. Now, I will demonstrate the configuration process of web server. So first, I will update the package repository on the Linux server using the command sudo apt update. This command ensures that the system has the latest package information before installing new software. Next, I will install Apache 2 web server using the command sudo apt install apache 2. After the installation process is complete, Apache 2 is available on the Linux server. Next, I will check the status of the Apache service using the command sudo systemctl status apache 2. The output shows that the Apache service is active and running. This confirms that the web server has been successfully created. To make sure that Apache starts automatically after the server is restarted, I enable the service using the command sudo systemctl enable apache 2. Then, I configure the web page that will be displayed to the client using sudo nano /var/www/html/index.html. So, inside this file, I create a simple web page containing information about our project. After saving the web page configuration, the web server is ready for testing, but first, I will restart the Apache using sudo systemctl restart apache 2 command and check its status once again. For the testing procedure, I will first check the IP address of the Linux server using IPA. Next, I move to the Linux client and test the connection with the server. After confirming the connection, I open a web browser on the Linux client and enter the web page with its server IP address. The web page created earlier is displayed successfully. These results prove that the Apache web server is running correctly and Linux client can access the web page hosted on the Linux server.
Okay, so I'm going to install database MariaDB server step by step. We're going to run sudo apt update in order to refresh its index packages. Just put in the password, okay, and then enter. Okay, it's done. Now we're going to run sudo apt install MariaDB server. Okay, enter. Yes, this will probably take a while. Alright, it's done. Now we can run sudo mysql underscore secure underscore installation so that we can install the MySQL securely. Enter the password. Alright, we're going to enter the password. Okay, no, remove anonymous user. Yes, yes. Remove this database and access to it. Yes. No. Okay, we've installed the MariaDB now. We will try to get into it. So we just run sudo mysql minus u root minus p. Okay, enter the password. Okay, we've get into the MariaDB. Now we're going to create a database. Create database. For name, we will try to put Fedora. Yes, because that's our team name. Okay. Okay, create user. Local host identified by the password 1. Okay. Maybe maybe there's a typo. We're going to try that again. Okay, so it doesn't work. Think I'm gonna try to create user Fedora identified by 1 2 3 4 5 6. Still no. Okay, that's alright. We're going to exit. We're going to try again. Sudo mysql minus u root minus p, enter the password as always. Okay, create database Fedora. I'm gonna try it's already exists. That's alright, we can start a new Fedora Linux. Yes, it worked. Alright. Okay, create user. I think I'm going to use Fedora as well, but this time I'm going to use the lowercase f. Fedora. Okay, at localhost identified by and then the password. Okay, looks good. We're going to it worked finally. Alright, so we are going to grant the privilege, grant all privileges on Fedora Linux. Okay, install to Fedora at localhost. Okay, and then some dot, enter. Okay, good. Now we will flush all those privileges. Alright, and then exit, and that's it. Okay, so we are going to demo. First, run the system control status MariaDB. Okay, enter. Alright, so it seems like it is running good. It is active and says it is running. Okay. Everything seems to be in order to me. Okay, so how to exit? Control X. It's not working. Okay, it's alright. We are going to see again. Okay, there you go, finally. Okay, so we are going to access our database. Now we are going to use a new way. We are going to use our username now in order to access our database. Fedora Linux. Okay, enter password. Access denied. Did I typo in any way? Let's try that again. Okay. Okay. Password. Denied again. I wonder. Did I use a wrong? We're going to access it manually. Root p, enter password. Okay, let's see what's the problem here. We are going to run a specific command. Select user from mysql.user. No wonder I use Fedora with the lowercase f. Alright then, we are going to try that again. So I'm just going to exit and try that again. Okay, mysql -u Fedora p, enter password. There you go. Alright, So I want to use the one that I've made, the database that I've made earlier. Use Fedora is the username, sorry. I'm going to try use Fedora Linux because that's the one that I've made earlier. There you go. So I'm using the Fedora Linux. We will try to create a table. The name I'm gonna put, since this is a demo, I'm gonna put test. We are going to put the info that required to be insert in the table name, varchar, if I'm not mistaken. Alright, how many do I want to put it? Let's say 20. Alright, okay, enter. Okay, so we are going to insert the value, insert into test the table. Okay, values, the ID I want to put 1, and the name, let's just put demo because this is a demo. Okay, there you go. Now select all, the star from test in order to display the table. There you go, the table is there. Okay, so now I'm just going to exit.
Why is DHCP better than manual configuration?
DHCP is better than manual configuration because it is automatically assigned IP address and network setting to devices. This DHCP provides several advantages such as reduce administrative work by the network administrator does not need to configure each devices manually. Second, it prevents IP address conflicts by reducing the chance of two devices has the same IP addresses. Third, it saves time because you don't need because when a new device want to join the network, it will receive the IP address automatically.
So my friend, tell me, what happens if the DHCP server stops?
If the DHCP server stop functioning, one of the things that will happen is some of the existing client may continue to working temporarily until the leases are expired. Second, new devices cannot obtain IP address automatically since DHCP stop functioning. They cannot provide IP address to the new devices. Third, expired leases cannot be renewed. Once the device lose their connectivity, it cannot contact the DHCP server to obtain a new leases. And last but not least, they may not be able to access the internet or communicate with each other on the server. That's all.
So, could you care to tell me why did you choose Apache?
Our group chose Apache because Apache is available in Debian repositories and it is open source and widely used and also stable.
I have a question actually. Why can the client access the web page?
Client can access the web page because client and server are both connected through the same internet network. And Apache is listening for HTTP requests.
What is SFTP?
SFTP stands for Secure File Transfer Protocol. It is a network protocol used to securely transfer files between a client and a server over a network. Unlike traditional FTP, SFTP operates through the SSH Secure Shell Protocol, which encrypts all communication between the client and the server.
So, what is the difference between FTP and SFTP?
FTP, File Transfer Protocol, and SFTP, Secure File Transfer Protocol, are both used for transferring files between computers, but they differ significantly in terms of security and operation.
What is the difference between database and table?
Well, a database is a collection of organized data that serves as a container for storing and managing information. Within a database, however, there can be multiple tables, each designed to store a very specific type of data. A table then consists of rows and columns, where rows represent records and columns represent attributes of those records. For instance, a database named StudentDB may contain tables such as students, courses, and lecturers. Therefore, the database acts as the overall storage system, while tables and the structure used to store the actual data.